Welcome back to Air Quality Matters, and I believe we already have the tools and knowledge we need to make a difference in our built environment. The conversations we have and how we share what we know is the key to our success. I'm Simon Jones, and this is episode 45. Coming up, a conversation with Tom Hayward. We talk so much on this podcast about the importance of performance when it comes to ventilation, to value good design, commissioning of systems, and just good all-round quality assurance. So in this episode, I talked to Tom Hayward, the MVH department manager at 21 Degrees, a department at the coalface of churning out some of the very best designs and installs in the UK. What is the philosophy that drives the team at 21 Degrees? And what perhaps can we learn from a company that has been at the bleeding edge of good ventilation outcomes for years? We talk about Tom and what he sees as the next important things the industry needs to focus on. Tom is down to earth, full of insight, and quite frankly, walking the walk day to day here. If you're interested in what good ventilation looks like, I think this is the podcast for you. Thanks for listening as always. Do check out the sponsors in the show notes and at airqualitymatters.net. This is a conversation with Tom Hayward.
We need to be able to stand over the performance of what these systems are doing. So as an organisation that focuses so heavily on that, I thought it'd be good to kind of run through with you and ask you some questions on what's it like looking at buildings and ventilation through that lens, and what does that mean practically?
Yeah, we see a lot of product spec over performance spec and no one really thinking about the performance. So we obviously start off looking at the performance and then look at what products we need to meet that performance.
And fundamentally, what does that mean? When you say we look at buildings through the lens of performance, like I send a drawing into you, I ring up your organisation and say, look, I'm thinking of putting ventilation. As an organisation that does that, how does that stack up for somebody?
Yeah, so one key thing we look at is, let's say one of the first questions we ask is, why do you want MVHR? What is the driver for it? Do you need it because planning has stipulated it and it's simply just a tick box exercise? Do you need it because you're going for passive house? And if so, then that opens up another discussion. What kind of heat recovery rate do you need to help with your passive house compliance? Because there's passive house certified units on the market. Some of them are 92% heat recovery efficient. Some of them are 80% heat recovery efficient. They're still passive house certified and they can be used in a passive house. But what people don't realise is you can go for a lower efficiency. You don't have to have the best one, unless your PHPP is telling you so. So if you use a lower efficiency one, you're wasting more heat and dumping it to outside. But if your passive house fabric is designed really well, that doesn't matter, and it's only minimal anyway. So
yeah,
do you need the best, most expensive unit, or can you have a slightly cheaper but still very high performing one?
And there are trade-offs as well, aren't there? Sometimes with heat recovery, that chasing a very high level of heat recovery might have a trade-off in consumption of fans or other elements of the unit that you may have a focus slightly elsewhere. I know that happens very much at a commercial level, that heat recovery, there's a real trade-off between chasing very high levels of heat recovery versus the kinds of watts per litres per second and energy consumption of the device, and you'll actually be graded in different calculations based on one or the other,
Yeah, there's some very good units out there that have a high heat recovery efficiency but are also very airtight in the construction, really well insulated, really low energy fans. So there are units that do it all, but whether you need one of them and whether you need to spend that extra, 600 to 1200 quid, you might not need to. It all depends on the energy balance in PHPP and how your building fabric's performing. which is really what dictates a lot of systems that go into your house, is building fabric.
So for listeners to be clear, 21 Degrees at the moment only sells MVHR systems. So when people are approaching you, generally they're looking at installing heat recovery. Would that be fair to say? So they've already made a certain journey to the point of saying, I think I want heat recovery, whole house ventilation as a design consideration. That they're kind of at that point when those phone calls or drawings come into you, at very least.
Yeah, exactly. Yeah, they've been working with their architect or a designer to design their building. We then send the drawings in, and sometimes they say, I want MVHR, or sometimes they say, my architect has said I need MVHR because I'm going for a good air tightness. So that's great. If they're targeting a good air tightness, great, because they're already qualified. They already know they need MVHR. Now it's just a case of telling them what they can get out of MVHR, rather than it just being a solution to an airtight building that you've created airtight so you've got no natural ventilation. It can come with many other advantages, so improved indoor air quality, improved occupant health, extracting the moisture to outside. It doesn't just have to be that heat recovery aspect that we look at, providing many other benefits.
That's a really good point. Yeah, that's a really good point. And when we talk about performance, particularly if we're looking through the lens of heat recovery, we're often drawn to the energy recovery side of this. But there's a provision of adequate ventilation side to this coin as well. And potentially, regardless of the efficiency of an exchanger, defining performance when it comes to flow of air, noise, comfort, all of these things are a very important part of that whole equation, aren't they?
And you get a lot of people who talk about payback period. So if I get an MVHR, how long till it pays for itself? And I always say, you could argue there isn't one, because the filters in the unit is probably the most expensive running cost of the machine. You need to change them twice a year and about £30 to £35 a set. So, your payback period is pretty much eaten up by the cost of filters. I'd see it more as an investment into your health and the health of the building. And the payback is done on your heating system, because we're reducing the load on your heating system by recovering heat. So that's where you get the payback from. Your MVHR unit itself isn't going to pay for itself.
No, it's an interesting point, that actually. And I remember we did a piece of work, must be 7 or 8 years ago, where we looked at passive house PHPP calculations with an architect down in Cork, a very well-known one. He used to chair the Passive House Association over in Ireland. And we took 2 or 3 of his well-known buildings that he was very comfortable with the calculations and the performance of those buildings. So he knew them inside and out, both from a design perspective and a real-world performance perspective of them. And we just swapped out the heat recovery element in the PHPP calculations for non-heat recovery. And from a payback perspective, and now bearing in mind this was before the fuel crisis, so cost of energy was quite a bit less at the time. But from a payback perspective, the additional cost in non-recovered heat was equal to the cost of filter replacements on an annual basis. So while the ventilation heat loss effectively doubled, as you'd expect it to, because you weren't recovering the heat, actually equated to, in real terms, cost terms, a net neutral impact because of the cost of the filter replacements. So you never really saw a return on that investment if you just looked at it through that lens. But I think that misses the point for a lot of people, is that the reality is if you're piping air into every room of the property, and it's filtered to some degree, and you're in control of that process, it's an air quality outcome you're chasing primarily. And as you say, a reduction in heat load on the property, which might mean a reduction in capital cost for a heat pump, for example.
Yeah, completely agree. A lot of people are putting it in for an air quality purposes, not just heat recovery. And the Passive House Trust released a document in think it was 2019, called The Case for MVHR, and we went back on what they'd said in the past was that MVHR isn't really required until you get down to 3 air changes per hour or less. Then we went back on that and said, actually, MVHR is good in all buildings in terms of air tightness. And in terms of heat recovery, that's never impacted by the building. It'll always recover. If the heat exchanger is 92% efficient, it'll always recover 92% of the heat that is extracted. Whether that's in a leaky building or an airtight building, the heat exchanger is still going to work the same. But
you're just diluting some of that energy impact. Yeah. I've had this argument actually here with building standards about that. And I can understand if you still man the argument, the other side of it, you can say, well, look, every building is moving to a more air tightness level. So is it really worth chasing leakier buildings? They're all coming to you anyway, eventually. Is it just not a bit greedy looking to put heat recovery into the leakier buildings as well? But the point is, I think a narrative was drawn with heat recovery over many years that it was an energy thing, and it only applied to advanced buildings. But as I've said to a lot of people in that industry, you get drawn into a lot of whataboutism that's very hard to argue because energy costs go up and down, ancillary costs of filters go up and down. It's a very hard one to actually quantify. But the one thing that is quantifiable, and most of the modelling that I've seen demonstrates that very well, is that if you supply air to every habitable space and you're extracting from every wet space and you're in control of that process, air quality outcomes are better. And it doesn't matter what the air tightness of the property is. I could be in a 15 air changes at N50 property, and if I'm piping tempered air into every bedroom of that property, I can tell you now you're going to get a better air quality outcome on average than you are relying on natural infiltration into that space. So it depends on your priorities, I guess. Most people fundamentally, this is about comfort and well-being.
Yeah. I think also going back to that other argument about airtight buildings are coming to us, so let's just deal with them. With the scale of retrofit that's required in this country, ventilation is going to have to be addressed, and it should be the first thing to be addressed. If you get the ventilation system in, then whatever air tightness improvements are done down the road, it's fine. The ventilation's already dealt with. Whereas what we risk happening is people improving the building fabric before addressing the ventilation, and then they get problems with indoor air quality, condensation, damp and mould. I personally did that. Even though I'm in the ventilation industry, I did improve. I started my room by room retrofit before I did my ventilation. So I did my living room up, made it airtight. My MVHR wasn't in yet, and I had big problems with condensation on those windows straight away. So my MVHR was rushed in.
The challenge is it does have to sit in the real world as well, and obviously with the existing housing stock, it's not always going to be possible, or it's going to be sometimes perhaps cost prohibitive to get full centralized MVHR systems into existing buildings. You must see that all the time at 21 degrees. You're looking at both new build, self-build projects, but also renovations. Buildings that it's quite possible to put centralized heat recovery in that are existing. It just requires a bit of forethought and innovation and sometimes a little bit of money spent at it to achieve.
Yeah, it's right. I'd say 60% of our MVHR jobs are retrofit, with 40% being new build, and most of those are deep retrofit, so they're going to a really high level of air tightness, so they do need MVHR, but also most of them are homeowners who are massively invested in getting the best out of the building fabric and also the ventilation. We know they need that to be done to a good level, so they want that performance. On the other hand, we do get some who see it as a nice to have, and they ask you for a quote, you figure out how it's going to fit in, and then you quote and we say, actually no, I think based on that price I'll just go for MEV, or I'll keep my traditional extractors and trickle vents. But I think when we talk about that price, it's often, let's say it's 5-6 grand. You'd pay that much for a rewire. But people see, well, that's electricity, so I have to have electricity, so I have to pay for a rewire. And I think the argument needs to change to be, well, actually, you need ventilation as well. You have to have good indoor air quality, or else your health suffers and the building suffers.
Yeah. No, I think that's a really good point. And it kind of comes back full circle to that opening question, really, about defining performance. And one of the things about defining performance is starting to define outcomes.
That's it. Yeah. You see so many product specs where it is just install X unit in this house without actually saying why you want to install that unit. What performance are you trying to get out of it? So switching over from a product spec to a performance specification is key, but so is educating the industry to be able to understand the product at a performance specification and educating customers.
And it's a simple reframing, really, isn't it? Often it's not. In fact, I've just been teaching this morning, and a large part of the conversation has been around that. Is about saying that this is just changing the narrative from equal or approved to what does this building need? And that you spend a lot of time at 21 Degrees doing that, don't you? There's a very rigorous process that a project goes through when it lands on your desk of that design intent.
Yeah. So a design shouldn't just be, say, a schematic showing 2D lines on a page, for example. A design really is looking at the performance, not just the layout of the ducting. So looking at pressure loss. So the resistance to the airflow through the ducts is something that needs to be looked at. That'll tell us how hard the fans are working to move the air across that ducting. How much is it going to cost to run? A key one we'll look at is sound. So is this system going to be inaudible while providing the airflow rates that you need? Because we go to some, or we speak to some people who have got MVHR, and they say it's inaudible, but I'm not getting the airflow rates. So there shouldn't have to be a compromise. You should be able to get the airflow rates that you need for that building whilst not hearing it, not really knowing the ventilation system's there. And then it's a case of obviously looking at how the ducting and things fit within the building, where the MVHR unit can go, and giving customers that peace of mind, really, that this system will be inaudible because look, here's a sound report that's all been calculated. We've got attenuators to show you how much sound is being removed, and once it's been installed, we'll come to site to commission it and check this, make sure you're getting these airflow rates, and make sure it's going to be inaudible.
Yeah, interesting. So tell me a little about that kind of process. Then you take a design into the organisation, and you'll do a full design for somebody. So that, like you said, isn't just we need X flow rates. That's the size fan you need, mate. Off you go. Or here's some X's where we expect the inlets and outlets to be. You're doing a full duct design where you're taking into account airflows, speeds, acoustics, pressure duct loss, all of the things that are important to understand that you can get a desired outcome at the flow rates and pressure losses that you expect. What happens with that design then? Because that's a good design and probably a level above what a lot of people get. What happens with that design then? People can then buy that equipment from you. Do you install as well?
Yeah. So when we do the design, we liaise with the architects, the frame designers, any project designers. We like to be in there nice and early, embedded within the design team. And often the end user is involved, especially if it's a self-builder or quite an involved homeowner. So we talk them through the system and where everything's running and what it's doing. That design is then passed to the client, the architects, and often it goes to a contractor, the main contractor who's installing it. We do some installs, some local installs. But we often find that, some of the best installs we've seen have been self-builders because they've never done it before. We're not bringing any bad practice with them. They're starting a complete fresh. They want it to work. They've got all these labelled drawings to show them where everything's going. So they do a really good job of the installation and they take the time. And our quality check is once the system's been installed, we'll come and check it and we'll check it's performing. If it's not performing, we know something has changed during install stage, or you'll be surprised how many times we'll get to site and someone says, "Can you take these bits back to your warehouse with you?" And there's a big silencer in there. So you know that it's not being installed, and you now know why the system's slightly louder. So we'd go about making sure that gets put back in to make sure the system's inaudible.
How do you deal with that gap of competency in the middle? Because you were saying at one end you can see quite good outcomes from people that don't have experience because they've got a good design to start with and they're vested in the outcomes here. They've got that diligence and they'll take care. But generally speaking, it's understood that we're trying to build the competency of the supply chain up. So that sounds quite opposite, actually, to what you hear in general terms. I guess perhaps a little bit because we're over-relying on the competency of the supply chain in order to pick up for lack of design and outcomes a little bit. And that's that false assumption that if I give it to a contractor, I'll get a good outcome, which we know isn't automatically the case. You're saying by bookending that process, having a really rigorous design and a really rigorous commissioning process, we can actually deal with a lot of the competency bit in the middle because the design intent is so clear and the outcome is so measurable that we'll pick up that issue in that process.
Yeah, it does help remove some of the performance gap because we're giving such a detailed design that and we've proven that it'll work. It's all been simulated in our software. So if someone then picks that up and they see all this performance criteria, they know that someone's looked in it and made sure it's going to work. So then it's their responsibility to install it as per the design to make sure that the end result is that performance that we've tried to get. And we spend an awful lot of time on the phone to installers or to contractors to help them with installing the system. And if they need to make any changes, they always run them by us just to check that it's not going to have a detrimental impact on the performance.
I was going to say that. What happens about the alterations to design mid-project? Somebody's discovered a steel where there wasn't supposed to be one, kind of problems. You do a lot of ongoing support to help people with those kind of revisions, basically mid-project.
Yeah, it's not a case of right, there's your kit. Now leave us alone.
Good luck.
We kind of hold the hand all the way through, to commissioning, and then even for servicing and after sales. So, 9 times out of 10, you get the odd project where it's designed, absolutely everything's been included on the drawings and it fits in exactly as you've designed it. 9 times out of 10, a steel beam might pop up that wasn't shown on the drawings, so no one really knew about it. And it's just a case of figuring out with the contractor how to get around that obstruction.
Yeah. What are you commonly seeing as some of the challenges in the projects to try and achieve things like good acoustics and thermal comfort and serviceability and so on? Where do you see those gaps appearing, and what are the kind of things you're doing to address those in kind of the design and the follow-up and stuff?
I think a big gap is lack of understanding of the technology. It's still quite a new technology, and we get a lot of customers who will come to us with the drawings and they'll say, I want an MVHR unit, it can go in my cold loft, or the ducting can go up there. And then it's an education piece for us, so quite a lot of our time is invested in saying, actually, you can't really put your unit in the cold loft. It can lead to inefficiencies. Same with your ducting. You want it all within the thermal envelope. Which you do inevitably lose some customers by, because they say, well, so-and-so said it can go in a cold loft, so I'll go back to them. But a lot of customers will say, I could spare a bit of space in my utility room so it can go down there where it's easily accessible and it's within the thermal envelope. And I'm willing to have a bit of lowered ceiling in the bathroom to run some ducting. So it's a bit of a compromise. Often, especially in retrofit, you need to compromise if you want to fit an MVHR system in, and you need to allow space for it.
Yeah. Is that a red line for you outside the thermal envelope for the systems, or is it just something that customers have to understand? Because I've looked at this a couple of times, and it's not clear sometimes from the actual manufacturers whether the product is suitable to be in perhaps some of the temperatures it might experience.
Well, but yeah, there are units on the market that are designed for cold roof spaces. Okay. Some manufacturers will say things like needs to be in a space protected above 5 degrees C. So really a cold loft isn't going to drop below 5 degrees C that often, and you could have a little frost heater for in case it does. What a lot of people will try and do is build an insulated cupboard around the unit in the loft, which can lead to complexities and access difficulties. For me, a really big one is access. How likely are you to go up through that loft hatch into a cold loft space, 3-4 times a year just to check on your unit, twice to change the filters, another couple of times to check things like the condensates running nice and clearly. In reality, you go in your loft maybe twice a year, once to bring the Christmas decorations down, once to put them back up.
Pretty much.
And we've seen, now that MVHR has been around for a while.
Summer. Yeah.
Yeah, exactly. Yeah. Now that MVHR has been around for a while, so, we're servicing systems now that we installed 15 years ago. You see a massive difference in systems that are in barely accessible roof spaces compared to plant rooms. The plant room ones are really clean and well maintained. The ones in a loft, you're getting faults on, they're very noisy, and they're just difficult to access. Out of sight, out of mind is our motto.
Yeah, and it makes it more challenging to insulate ductwork if it's all coming to one place in a cold space attic as well. It's fine for odd runs and bits and bobs to pop in and out, perhaps, of the thermal envelope if they're treated and managed properly. But there's a lot of infrastructure around the heat recovery unit that's very difficult to do well if it's in a cold space, isn't there?
That's right, yeah. And even if you do it well, it's like you insulate a duct with foil-backed mineral wool and then you tape it. How long is that tape going to last? We're very specific about what tape we'll use on the insulation because we know most tapes will fail after a few years. Yeah. So it's just small things like that people don't consider could go wrong, and it could lead to quite bad impacts like condensation ripping in your roof. Another thing,
finding a big differentiator with you is acoustics, that you're paying a lot of attention to velocities and attenuators and design flow rates and so on. Because from what I've seen, you do a lot with spiral ducting and proper calculations and so on. Whereas there's quite a big, I'm not saying that radial ducting is a bad solution, but it's seen as a get out, I think, from proper design sometimes, that you just stick a whopping great plenum and run lengths of snake around the property and you don't have the same considerations that you might have with a properly designed spiral system.
Yeah, I'm a bit on the fence about this. I feel like semi-rigid does get quite a bad name, but I think that's because a lot of low-quality companies supply semi-rigid systems. We've just done semi-rigid systems for a 47 passive house scheme, and they're certified passive house, and they're all semi-rigid. If it's designed well, so if you make sure you've sized the ducts properly to carry the airflow rate, because the ducts are smaller, then it can perform as well as rigid. Rigid tends to be easier to manage pressure loss, for example, because you can simply just increase the size of it. Whereas with semi-rigid ducting, it's only one size. You have to put 2 ducts, maybe even sometimes 3 ducts to every room. So I think so long as it's done properly and it's well designed, it can perform as well. And I always say to anyone who's considering MVHR, ask whoever's doing the design to provide you with sound data at design stage. So you want to know how loud that air valve in your bedroom is going to be before it's installed. If they can't tell you that, it's very unlikely that they're designing properly. It's likely to just be lines on a page, which you see a lot of free design services out there, which, there's a reason it's free.
Yeah, and I think that's always the risk with solutions that provide some convenience, which semi-rigid does, that people see that as an opportunity to not think stuff through. I've seen really, really good installations with semi-rigid ducting that perform as well as anything else, but I've also seen terrible installations, and there's not much you can get wrong with semi-rigid from an installation perspective, but if the design is out, then it's not going to perform, and so there has to be that proper intent at the beginning, I think is clear. And is it quite hard to do the acoustic designs and the flow rate designs? Is that a skill that you just don't see being employed out there effectively enough? Because I've seen your designs; they are very detailed from a flow rate perspective and an acoustics perspective. You don't see that level of detail very often out there.
I think it's for time. A lot of people say they'll do the design to accommodate the sale. They know that they need to do the design to get the sale, so they do a free design. Our design isn't free; we charge for it. That is because of the time spent in doing all that acoustic design, all that acoustic simulation, doing all the airflow simulation, checking everything works together, checking it fits within the structure. And there's software out there that can help with it. So we have software in-house that helps with our design. And although you do need to have the understanding of physics and acoustic understanding, the software does a lot to work with you on it.
Just going to grab your attention for a minute. I wanted to quickly tell you about Lindab, a partner of this podcast. For over 60 years, Lindab has been dedicated to improving the climate of buildings. I have known them and some of the great people who work there for as long as I have been in this industry. Lindab offers a broad range of products, from individual components to complete indoor climate solutions. Their systems not only promote better indoor environments, but also deliver economic benefits. If you're working on a new building project, Lindab's high air tightness products and demand-controlled ventilation systems are designed to meet the stringent energy efficiency requirements of today and align with environmental certifications. If you're renovating, Lindab's smart units can upgrade existing systems, reducing energy consumption by up to 70% with minimal impact on the building structure. Lindab's products meet the certification standards for BREEAM, LEED, DGNB, and many more, ensuring optimal environmental performance. And if you're looking to simplify your design process, their range of ventilation software and tools make product selection, calculation, and performance evaluations quite straightforward. Creating healthy spaces is at the core of Lindab's mission, which is why at Air Quality Matters, we are so pleased to have them as a partner with this podcast. Do check them out in the podcast notes at airqualitymatters.net and, of course, at lindab.ie. Back to the podcast.
Is that just the reality of different markets? Obviously you've got, I'm guessing, a higher end market that you're working with, people that are vested in more time, perhaps prepared to spend money up front on designs. Do you see that filtering down into the mass house building or the lower echelons of construction? Where do those? It's a hard pitch, isn't it, to ask somebody to pay for design when you've got manufacturers that are going, no, we do designs for free, and differentiating the difference between those two designs.
Yeah, it's really hard, and a lot of people get prices from us and prices from someone else, and they think we're comparing apples and apples, but it's often apples and pears. There's a few companies in the industry who we're on the same level as, and our pricing is very much the same because we're all of the same quality. I'd say there's two markets for MVHR at the minute. There's one who want it doing really well and want it to perform, and they want to get all the benefits. And there's one that's just to tick a box for planning or for the building inspector. And really, if you're spending a couple of grand ticking that box for the building inspector, why not spend a couple more and reap the benefits of a properly well-designed system? In terms of mass house builders and lower echelons, I think it'll take a change in building standards for it to get that far. One of the reasons we get a lot of passive house jobs is because we can guarantee that performance, and the contractor knows that they have to deliver this performance, so we can take that responsibility off them and we can meet it. A lot of our customers are repeat specifiers, repeat architects. We know that if they bring it to us, we'll deal with everything. We'll make it fit within the building, and the result at the end will be what the design intended.
Yeah, that's interesting, isn't it? That drive of being guaranteed results or performance outcomes. It'll be interesting to see if that has an impact in other jurisdictions where it doesn't look like it's happening in the UK anytime soon, but we certainly see it in Ireland and in France and Belgium, where there's this independent inspection of ventilation systems post-completion. And that really turns the screws on systems that don't perform. And if those systems can't perform because of poor design, eventually that's going to elevate the value of the design over time. That people are going, this is the fourth project I've spent hours trying to unpack trouble because of a poor design. Somebody might actually start paying good money for the design, And look, mass house building's great because of the replicability. There's no excuse for it, really. You're coming up with a decent design for archetype A and archetype B and archetype C. You've only got to do it right once. Like it's not like retrofit and self build where every flipping project's different. You've got 250 very similar properties, on an estate. Like just pay the money and get a decent design, and be done with it.
Yeah. I think also I always ask the question: are you paying your structural engineer? Are you paying your architect? Who did someone design your car, for example? You wouldn't build a car without designing it first and knowing how it's going to perform before you build it. I see it as the exact same thing. You wouldn't just expect someone to do your structural calculations for free, for example, and spending a bit more to get it right first time is much cheaper than having to spend again to take your system out and put a new one in, take your ceilings down. Much less trouble. We work a lot with consulting engineers who kind of pass us the MVHR design, and that works really well. And I do believe that you can't specialise in everything. You can't be a specialist in every single building service. There is some stuff that you're gonna have to farm out to specialists. And I think the more the industry works together on things like that and making sure everything's done properly, the better.
So where do you see it mostly going wrong? Most of the stats that I see for non-compliance of mechanical ventilation with heat recovery or poor performance with mechanical ventilation with heat recovery seems to be on either flow rates, so balancing and getting it delivering the basics right, or acoustics. People seem to be getting that. I mean, there are idiots that make silly decisions on what ducts to insulate and stuff blowing where it should be sucking and all the usual horrendous stories. But like those aside, like generally where we see underperformance seems to be flow rates and acoustics. What drives that, do you think? Is it just an assumption that you can give the supply chain very basic designs and they'll somehow cobble together a good outcome? Is it as simple as that, or is there more to it? I think
I agree that it is usually down to acoustics or airflow or lack of, and I think it is down to the industry. People not really understanding what they're putting in before they put it in. So we saw a big project recently where the electrician said, "Oh yeah, I'll do the MVHR. I can get hold of them parts." So he put the MVHR in and all the ducting system, and it wasn't connected up properly in the floor joists or the ceiling zones, so the airflow wasn't making it to the room. It was leaking in the ceiling voids and things. But I really feel that if he knew what the intention was of this system and what it needed to do, I feel like that could have been avoided. I think there's a lot of learning for the industry and the people jumping into the industry. People see MVHR as this up and coming thing. There's a massive opportunity there, and try and jump onto it, but there's a lot to learn before you do take that leap and start offering it.
Yeah, and it strikes me in the context that we're talking about MVHR here. We're talking about fairly benign environments. You know, we've got listeners to this podcast that are in the tropics and in the Nordics and northern Canada and Florida and Australia, West Coast and East Coast. You know, that there are some very specific environmental conditions that you have to take into account in some parts of the world, and making decisions on whether an enthalpy exchange is the right decision and how to deal and control humidity in the spaces effectively. And like, it gets right complicated right quick in a lot of parts of the world. Here it's fairly benign. A good solid MVHR system designed well for flow rates, you're not exposing it to too many quirky environmental conditions. It'd be interesting to see if that changes with climate change. But I'm guessing in your calculations, you're not having to consider the humidity you're trying to hold that building out and the control mechanisms that might need to adjust that for different seasons, and you know, that kind of stuff.
Yeah.
We're not at that level here even. You know, this is just
we're
basic,
not really
solid airflows we're trying to deliver.
It is, yeah. Most of the time it is, and the systems that we use will monitor the humidity internally and increase the airflow rate if we need to. But that's another thing we've seen is I've asked. We deal with a lot of faults where people have had issues and they phone us and they say, "You didn't install our system, you didn't supply it, but can you help us out?" And I'll ask them why they've got an enthalpy unit, and they say, "Oh, it's so that we didn't have to worry about a drain run." And I think, well, so you've got an enthalpy unit just so you didn't have to put a condensate drain in, not because you need enthalpy recovery, but because you didn't want to put a drain in. And that just really sums it up, where there's not much thought really gone into what is an enthalpy unit and do I need one. It's just a thought of how easy is it to install. We see a lot of, with regard to climate, we see a lot of with the introduction of Part O.
Overheating. I was going to ask you about that. Yeah. Is that something you're having to pay closer and closer attention to now?
We're having to be careful of it because some people are putting MVHR in to comply with Part O, but this is often someone who's already done a design. So we might get a design from an M&E consultant saying, "Can you provide a price to supply this?" And we'll look at it and we'll say, "Well, you've got 120 meters cube per hour of air going into this one bedroom. It's a lot of air. Well, it's needed for Part O compliance. Well, how's the air going to get out of that bedroom when you put it under such a positive pressure? How big is the door undercut going to need to be? What about the back pressure on the air valve, meaning that it just stops supplying? What about sound? You're going to have to have a 250 mil duct, 150 mil ducts to make sure that's quiet with a big silencer. So Part O, you can't just say, right, throw a load of air in there and there you go, Part O's complied with. You need to think about, how can I put a load of air in there? Or is there a better method, such as better building fabric design? Maybe some solar shading.
What's your gut say when you look at this? I mean, my understanding is there's only so much mechanical ventilation can do for overheating. At the end of the day, it's a fabric shading, solar gain problem to manage. Yeah. It's less. You just can't throw at some point, air changes. It's a law of diminishing returns when it comes to overheating. At some point, you have to start conditioning spaces. You know, at that point.
Yeah, I completely agree. And you start designing ventilation systems not for the occupants and their health, but simply for Part O compliance. No one needs 120 meters cube per hour of air in a bedroom.
No.
So it usually does point to a building fabric, a design issue. And if someone's got problems with overheating from solar gain, so if there's a sun beaming through a window, I always say don't even consider trying to cool it with MVHR. Don't put a cooling coil on because you'll waste your money. The rate of overheating from solar gain is much faster than the rate of cooling that we can supply with MVHR. So save your money and get an aircon unit, or even a plug-in one. Yeah, some decent shading. Plant a tree outside, or the plug-in air conditioners are great because really you might need it 4 or 5 times a year. Just pull it out of the cupboard and plug it in the problem areas.
Yeah, like I say, in this part of the world, we have very few problems when it comes to that. Although, I mean, I understand in certain urban environments, overheating is becoming a real challenge. People are sitting in conditions that are stressful. Physically stressful to the body, and that is a real problem. But like in the grand scheme of things, this should be manageable for us if there's a bit of thought for. I was working with a housing organisation up in Scotland, a guy called Duncan Smith. Shout out to Duncan if he's listening. But they were looking at retrofit for social housing up in Glasgow, and he was actually putting groundings in, or considering groundings in, the external insulation for shutters on windows in Scotland because of climate change. I mean, that's some serious forward planning that you go, well, look, this external insulation's going in for the next 30, 40 years. There's a good chance in 30, 40 years' time, you're going to want shutters on your window. So when you're putting the insulation on, now's the time to do it. It doesn't have to be, you don't have to do anything with it, but do it now before you have to worry about it, because shutters are the solution for a lot of the overheating problems,
Yeah, it's true. And you don't have to be in a hot climate to overheat, do you? Just the sun shining through a window. So we see a lot of external blinds on our windows. And,
there's a lot of horror stories, I think, from apartments and things like that in urban areas where they're nasty. Some really nasty conditions are being generated. I was going to ask, do you are you starting to have to think about outdoor air quality in some of your design considerations at all? Are you starting to look at the type of filtration of incoming air with some of the projects you're working on?
Yeah, some of them, especially projects in air quality management areas, so inner city centres, where MVHR is often stipulated as a planning requirement, so that the occupants don't have to open their windows for ventilation and let noise in and polluted air in. So then, yes, you're bringing air in from potentially a busy street, so you'd need a NOx filter on it. A good NOx filter can increase the cost of an MVHR system quite significantly. So that really does need considering in the budget planning.
Yeah, but it's in the regulations now. You have to consider outdoor air quality as part of the design, and if you're in an area like that increasingly is becoming a design consideration. So it's interesting you're seeing that practically coming across the desk. I mean, how's that flagged, generally speaking? I mean, are people coming to you and going, it's in this area, or are there certain checks and balances you're putting into place to go, have you considered this? We note that this is where you're building.
Yeah, it's often presented to us. So they say, I need MVHR because of local air quality. But we don't necessarily refer to the needing to be a high level of filtration on the intake. We refer to, I can't open my window because of local air quality. So then we have to tell them, well, actually, if you can't open your window for local air quality, then we need to put a better filter on your intake as well to filter it out. Often, though, we're looking at it and we're saying, right, you've got a busy main road right next to your house. We can only gain take over that road. We can't go anywhere else. It might be a terrace, for example. So we're going to need to put a NOx filter on. And we'd pre-warn them to let them know what cost they might be looking at. And we'd have to put one on there. But people often think, well, I live out in the sticks, so my air quality is great. But what you need to consider there is agricultural fumes and chemicals, pollen, especially in harvesting season when the farmers are all cutting the fields, and also in winter. So where I live, there's someone down the bottom of my garden with only heating his wood stoves, and as soon as autumn comes, my intake smells really strong of wood smoke. So we have farmers who have got MVHR and they're surrounded in people with log burners, so they have to have carbon filters on their intakes.
Yeah, that's interesting, that, isn't it? The false assumption that it's a urban problem. Yeah, I mean, same here. I'm in rural Ireland, and come winter time, between the peat and coal and damp wood being burnt around the place in various stoves, like you wet your finger, you can wipe the black off the white wood of the windows with the soot and stuff that's in the air, and that's being brought into the property. There's no doubt about it. You can smell it when it starts. Like physically, what does that look like for people if they have to start thinking of decent filtration, whether it's, would you go as far as HEPA filtration, so kind of MERV 13 and above type products, or like, do you make filter choices for people based on environmental conditions, or is it either basic and then a big NOx filter, or is there some considerations and stuff in between those two extremes?
Yeah, so there's basic filtration, which is, I've not really got problems with air quality. So you just go for the basic filtration, but then there's filtration for, like you might have an active carbon filter if you've got problems with smells coming in, for example. Or you might have a NOx filter if you live in a polluted area. And yeah, there is HEPA filtration available. Don't think I've ever used a HEPA filter. But they're typically reserved for special medical situations.
Yeah, fair enough.
But they are available for MVHR.
And what's that infrastructure look like for somebody? I mean, I think most people at this stage have got an idea what heat recovery looks like and big ducts. I mean, anybody that's looking at the video versions of this will see big ducts coming out of something behind you. But if you then have to look down the barrel of extra filtration on incoming air, is it just another box somewhere in line on the ducts that has a series of filters in it?
So let's say a NOx filter is a similar size to that, but it'd go on the black duct, so it'd go on the intake duct. Yeah. So you just need to make sure that you've got space on your intake duct to accommodate a big bulky NOx filter.
So again, access is really important. You're chucking this up in the attic or somewhere that's not so accessible. Those filters will need to be replaced relatively regularly.
Yeah. Sorry, it doesn't go on the intake duct. It goes on the supply duct of the MVHR system. The reason it goes on the supply duct is that it's then pre-filtered by the cheaper filters inside the unit.
Exactly, yeah.
So you change them as you usually would, and then your NOx filter might need changing every 3 years or something like that.
Did you start out in MVHR and ventilation with Green Building Store?
Yeah. So my background is architectural technology. So I did 4 years in architectural technology at Northumbria University. I then worked in commercial architecture for 2 years, and it wasn't kind of looking at low energy or sustainability, which I was really passionate about, especially in domestic dwellings. So I really did want to move, and I was aware of Green Building Store because when I was at university, I'd done my degree on passive house and comparing it to Code for Sustainable Homes at the time. And I'd used Green Building Store's case studies as reference. So I was always looking on Green Building Store's website, and then I saw this job pop up for MVHR. I didn't have a clue what it was, but I applied and I got the job. So it was quite a change for me. It was quite a tough decision to make that step, but I knew that passive house and low energy was where I wanted to go, and I could really see, the stuff I'd learnt at uni and the buildings I was seeing being built around me. I just thought, why are people still building like this when there's so much better ways and better outcomes that we could be aiming for? So that really drove my move over to Green Building Store. I've been here for 10 years now. I'm in my 11th year. And I started off as an MVHR designer trainee. And then after a few years, I became design manager, and I'm now department manager.
So you oversee a whole department of people, managing. How many people in the ventilation side of 21 Degrees now?
There's 19 in our department, so that consists of designers, admin staff, selling the products once we've designed them, sales teams providing quotes and helping deal with enquiries and speaking to people. And then we've got commissioning engineers out on the road all the time doing commissioning, servicing, and dealing with any after-sales faults or anything like that.
Yeah.
Big team.
And for listeners that don't know 21 Degrees, it's not just MVHR you do a whole range of things to do with high-performance buildings, don't you?
Yeah, that's it. Yeah, so we provide the knowledge to go alongside the products for low-energy homes. So we provide MVHR, provide triple glazed windows and doors, and that knowledge that brings it together. We also provide airtightness products and specialist insulation products. But what we try and get across to people is, you can't just buy a really high performing triple glazed window and put it in your building as you would traditionally. You need to consider where in the insulation line it sits to minimise that thermal bridge. You need to, if you're buying a really well sealed triple glazed window, why then put a trickle vent in it? It makes sense to get rid of the trickle vents and put mechanical ventilation in it in the house. And if they're not suited to MVHR, if they say, well, I'm only replacing my windows, we'd say, well, still do away with trickle vents and get a better extract system. So get an MEV system, for example. Don't put massive trickle vents in your high performing windows.
Yeah. And do you touch other ventilation systems other than MVHR? Not at the moment. You basically focus on MVHR. Yeah.
Yeah, we focus primarily on MVHR because there's a lot of work to get it right, and we see there being a really big opportunity. But there's a huge opportunity for other options such as MEV, especially with the scale of retrofit that's required, and the budgets involved in those retrofits often aren't 100,000. They're often several thousand. So MEV is often a good way to go for those projects.
Yeah, no, for sure. And you were saying that you also get involved in the commissioning. You've actually got a team on the ground that do the commissioning side of this. So some people would buy your product, either install it themselves and engage with you to do the commissioning, or work with contractors and get you to do the final commissioning and checks. Did I understand that right?
That's right, yeah. So we have two guys out on the road all the time doing the commissioning once the system's installed and once the house is ready to move into, really. Often the occupants are already living in there. And that it goes back to that independent check on the ventilation system that you have in Ireland. The installers installing it were checking it as an independent person. It's kind of checking that install and checking it's all working as designed. And I think if England could follow suit in having that independent check as a requirement on all ventilation systems, I think there'd be a massive shift in the market and we'd see much less issues.
Yeah, it certainly put a bit of pressure, turn the screws on some of the outfits that are walking away from stuff with no sense of what it's really doing. Because the reality is building control are never going to be in a position to check ventilation systems. I've never seen a building control officer with a wind vane anemometer to check the flow rate of a system. Most of them wouldn't know what one was. So, if nobody's checking, and construction hasn't got a great record for doing the right thing when it knows it's not going to be policed, we're surprised at the outcomes. So that independence of checking is so important. What does commissioning look like for your team? How long does it take for commission typically on your properties? I guess because you're doing a lot of self-builds and renovations, they can be bigger or more complex than rocking through 25 3-bed semis on an estate. Perhaps there's a little bit more to it, but what kind of investment in time should you expect, do you think, for commissioning to be done properly?
Yeah. So we did, so like the smaller social housing, we did 9 of them in 2 days. with two of us. With a, say, one-off build, I'd usually say to expect us to be there for 4 hours on site. And
half a day.
At that time, at that time, ideally, all the doors and windows would be shut and certainly installed. There'd be no one doing tiling on floors or anything like that, because we do need to go in every room. There'd be no one putting wet paint on ceilings, because we need to put our airflow hood against the ceiling. And when we get there, we're setting up the unit, because it comes with factory defaults, so we need to set it to as it is, that it needs to be set to deliver those airflow rates. And then we're balancing the ducting system, so we're trying to get a certain amount of air into each room. Often it's a different amount of air in each room, so the ducting system needs balancing to make sure that we're delivering that amount of air. So we'll take an airflow reading in one room, adjust the air valve, take it in another room, adjust the air valve, but then because we've adjusted that air valve, we'll then need to go back to the other room and all other rooms. So it's quite an iterative process, but it keeps the engineers fit.
Yeah, no, for sure. Yeah, what's your how many rounds typically does it take for you to zero in on a well-designed ventilation system to the flow rates? 2 or 3 kind of go arounds, or so you're getting in the ballpark on the first one, getting close on the second run round, and then zeroing with a bit of backwards and forwardsing? Does it kind of look like that?
Yeah. Once you're an experienced commissioning engineer, you might do 2 or 3 rounds. Sometimes it might be 5 or 6 rounds. You can often get a complete curveball where you think, why is this air valve supplying so much and the others are all struggling? That often points to, something was changed at install stage. But when we do the design, our model actually tells us, of the calculations that we use from our model, we can figure out how far open or how far closed that air valve needs to be. So basically how much damping pressure that run needs. So we can almost get to site, look at those figures and preset it, go around, check how accurate it is. It's not bang on, obviously, but we just then have to go around and tweak it so that it is bang on. So again, that harps back to our design being so thorough. It gives us that level of detail for commissioning.
What did you think about the suggestions in the regulation changes to do pressure drop calcs on the ductwork? Do you think that will make it through? And I'm guessing that's not something that would worry you particularly, but for knock it out quick installers, it might present a bit of a problem.
Yeah, I mean, it's a funny one because I think it's a good idea. It's more time for us spent on site, which could inevitably drive the cost of commissioning up. Although, if you're for right tools, then it can be quite a quick job. But yeah, I think again it could completely change the market. It could tip the market. People won't get away with doing things wrong, hopefully. But having said that, who's going to be checking that? Who's going to be saying, right, we've given these pressure calculations, that's correct? Because we've been to jobs to help out where it's been signed off. There's a commissioning report, it's been signed off, the building's habitable, building regs are happy, and we go to site and there's no ducting connected up to the air valves, so there's actually no ventilation, but someone signed it off.
Yeah. It's just makey-uppy numbers.
So if that commissioning certificate is given to the building control, they just say, oh great, it's got a signature on. That still doesn't mean it's working, so it's what lengths you have to go to really police the industry. It's a difficult one.
And there's always another layer, right? You can make the same argument of the validation that, a validator can turn up who's not really independent, put down numbers that satisfies the client because that's his biggest customer, and who's going to check that? So there's always that level of accusation, but at least within the standards, if there is that, theoretical independence and there is a check at least on every system, the great thing is that's the start of a data bank, and you can start to spot non-compliance just purely on the numbers that you're seeing. And I take it you guys are doing the unconditional testing method. You're using powered flow hoods and things like that for doing testing on the systems. That's another thing, another area the industry's got to catch up a bit is on the usefulness or not of unpowered flow hoods. I think we expect a bit more out of them than we get, to be honest.
Yeah. I mean, they're obviously expensive, but it's an investment that's well worth it to make sure that you're getting, again, that going back to performance, to make sure you're getting that performance.
I mean, me and you could be on the same soapbox here, to be honest, mate, on that one. I mean, I kid you not, literally just done a 3-hour workshop with a housing organisation, and a large part of it has been, how do you reframe the narrative to performance outcomes from product outcomes? Because until a measure of success is not, I installed a little white box on the wall and the electrician wired it up, to what did the property need and is it getting it? Until there's a switch in that narrative, I think we're still just going to repeat the same mistakes that we keep making, because there's just this assumption that if you tell the supply chain to install a bathroom fan, that you'll get a good outcome. And we just know that isn't the case, you know?
Yeah, we have a lot of people who want one particular brand of unit, and they say, I want this unit because I've heard it's really good. And we have to say, well, yeah, it is a really good unit, but what partly makes it good and what gets the best out of it is the ducting design. It's completely down to the ducting design. Yeah. And you can take the best performing unit on the market, and if you connect it up to a badly designed ducting system, it won't perform. Whereas you could take a lower specification unit and connect it up to a very well designed ducting system, and it will perform. Might not be the best, but it will ventilate. Might be a bit noisy, might not have the best heat recovery, but it will give you the ventilation that you need if the ducting system is well designed.
Yeah. It's just changing that narrative, and it's we'll see how we go. We'll keep shouting from our soapboxes, Tom. Listen, Tom, it's been brilliant talking to you as ever. Thanks a million for taking the time to talk to me on the podcast. Thanks loads.
It's been a pleasure. Thank you.
Thanks for listening. Before you go, can I ask a favour? If you enjoyed this episode and know someone else who might be interested, do spread the word and let's keep building this community. This podcast was brought to you in partnership with 21 Degrees, Lindab, ACO, Ultra Protect and Imbiot, all great companies who share the vision of this podcast and aren't here by accident. Your support of them helps their support of this podcast. Do check them out in the links and at airqualitymatters.net. See you next week.